Okay, in part one, we learned how to write in binary. And just a review, if I needed to write like the number 129 in binary, I could use this little conversion chart thing and be like, okay, 129. Well, I would need 128. I wouldn't need any of these things, but I would need one more, right? 100000001 in binary is 129 because it's just 128 plus 1. Okay, so that's our review. Now we're moving forward. Computers only understand ones and zeros. When you type in a number into a computer, it takes that number and it converts it into this thing, this binary system, because that's really how computers work. And so then the question becomes, how does it convert it? How does it know? Like, how does it know when I type in 5 to be like, oh, 5? Well, I'll just turn that into 101. I mean, technically, what the computer would really do is it would go all the way up to here, and it would be like, oh, 5, that's 000000101. Technically, that's what the computer would turn it into. And when the computer did, or if you did another example, if you're like, hey, computer, take 16 minus 4 and tell me what the answer is, the computer would figure out the answer to 16 minus 4 and then say, oh, the answer to 16 minus 4 is 000001100. But it's not going to tell us this is the answer because it knows we humans don't understand binary very well. We can figure it out, but it's not the way our brains think. How does the computer know to put on the screen, oh, the answer is 12? How does it know this turns into 12? That's a great question. I'm glad you asked it. Well, the answer is this thing. Actually, technically, this isn't really the answer anymore. It used to be. Now computers use something different called Unicode. But let's not get in the weeds here. Okay, so a long time ago, computers did used to just show 0101110, and humans had to really struggle to read it. And some brilliant people decided that's no way to live. Computers are worthless if we can't see letters and numbers. So some very smart people said, let's come up with a code that the computer can use to translate all those zeros and ones, that binary, into language that human beings can understand. And what they came up with, there's actually a few different versions of this, but they came in and they said, hey, let's make this thing. So you'll hear people call it ASCII. ASCII. So you hear people say ASCII or whatever. This is one of the first attempts they came up with to make a code that will take those zeros and ones and turn it into something humans need. Now, I used this one here. I'll tell you, all of this stuff here, you don't care about. You don't. So basically, what's funny is all of this stuff on this side, it's not helpful at all. Ignore it. For what we're going to do today, let's really just focus here with our letters and our numbers. Okay, how does this thing work? And so there's the letters, and then we've got numbers over here. And then if you want to get real fancy, you can include all these kind of special characters, question marks and percent signs or whatever. And even if you want to get super fancy, you can do capital and lowercase letters too. But let's not worry about that. Let's say like, hey, what if I just wanted to write the letter A? And I wanted you to do it in binary. What would the computer see if I type in the letter A? Okay, this thing that says hex, totally ignore that. Let's not even pretend to care about that right now. Maybe later we'll talk about hexadecimal. Let's just focus on, hey, if I want to type in the letter A, it says the letter A is the same thing as whatever the number 65 is in binary. Okay, well, let me go back to this thing. How would I write the number 65 in binary? Let me get some space here. Okay, how would I write this number 65 in binary? Well, 65 would be nothing there, 1, nothing there, nothing there, nothing there, nothing there, nothing there, 1 there, because 64 plus 1 is 65. So in binary, 65 would be 0, 1, 0, 0, 0, 0, 0, 1. Notice how there's 8 numbers there. We call that an octet. You want to get real fancy, an octet, 8 digits. So 0, 1, 0, 0, 0, 0, 0, 1, according to this code, is the letter A. What if I wanted to write the letter B? Well, the letter B is 66, right? It's just one more in human numbers. In a computer, 66, well, I've got everything I've got so far. 64, nothing, a 1 in the twos place, and then so 60. So B would be what? 0, 0, 0, 0, 1, 0 equals B, and so on and so forth. Now, these are technically capital letters. The computer, because we humans use, at least in English, we use uppercase and lowercase. The computer would be like, oh, a lowercase a would be the number 97 in binary, and the lowercase b would be 98. But this is it. This is the code, right? This is the code that the computer uses, or at least used to use. Like I said, it uses something bigger now called Unicode. It's kind of the same thing. It just has more stuff. This table in the Unicode would have way more things. And on your cell phone, by the way, when you're using emojis get their own number now. They get there because they have like, hey, smiley face emoji. Computer, sorry, the phone doesn't know what a smiley face emoji is, but it's like, oh, 011000111 blah blah blah. That's a smiley face emoji. There's a code for that too. So ASCII, I'm using this one because it's one of the more simple, small ones to understand. Most things now you have, because there's more stuff to know, you have to use this Unicode thing, but this is a good start. I told you there was a way to, because this, I mean, you see, this would take a long time to write a message, right? It's kind of amazing that if I told you to write, hey, write the lyrics to "Mary Had a Little Lamb" in binary, it would take you a couple hours probably. Computer can do it instantly. I'll show you. Mary had a little lamb. Its fleece was as white as snow, and everywhere that Mary went, that lamb was sure to go. Okay, I'm going to stop there. Man, computers are fast. Did you see it here? I'll show you. Look up. There it is. That's everything I just typed in binary. Mary had a little lamb. Doesn't make a lot of sense to our human eyes, but by the way, the cool thing about this website, I'll put a link. Hopefully the internet doesn't block it. You can take anything. So you can take anything you want. Hello, you are cool, and it will just turn it into binary. And then it's not, I mean, it's kind of fun, but then the flip side is anything that's written in binary, you can paste it, you can copy and paste it in there. See how I did that? I copied the binary right there, and I just pasted it, and then it just turns it back into regular old English letters that we understand. Isn't that fun how fast a computer is when it comes to calculating those zeros and ones? It's kind of what the computer does best. So this website will convert things to binary. So you could theoretically make a secret message. So you could, like I said, you could write it out by hand. You could do this whole bit, or you could just use this. It's probably faster. Meet me at the park after school today, and then copy it, and then you could send that secret message off, and anybody who intercepted the secret message would just see a bunch of zeros and ones and be like, apparently the printer threw up all over. I don't know what happened. But then when your friend got the secret message, they could say, oh, okay, I'll just paste that into this thing, and then meet me at the park after school today is the secret message. Now, this is not, and I'll say it one last time. This isn't a very good secret code if someone walks by and they know what, if someone sees a bunch of zeros and ones, there's a decent chance they're going to go, that's binary. I could probably just copy it, put it online, and figure out what the secret message is. Not so secret then, right? So this is not going to protect you fair. It'll protect you from people who are lazy, who are just like, I don't know what that is. I don't care. It won't protect you from people who are like you, who are smart, who took these classes and understand, right? But at the start, you could even, this is where you get into some good cryptography. You could even go all the way back to lesson 1. You could take that Caesar cipher, and you could use the Caesar cipher to write something in a substitution code, right? Then you could take the code from that and translate that into binary. So then, even if the person decodes your binary, they're just going to see a mishmash because you use the Caesar cipher. That would be so. Once again, if they're really determined, they could be like, "Ah, oh, it's probably a Caesar cipher. I could probably figure that out and decode that too." But every time you add a layer to that, you make it more difficult for the person to decrypt, to decode, to figure out what your secret message was. So I hope you've enjoyed this. There are way more codes, and the cool thing is you can even, once you learn some of these, you can make up your own versions, kind of like we did with the pig pen, where I'm like, hey, if you don't like it, then change it, make it different, use different shapes, right? Yeah, you can make up your own codes. You can learn brand new codes. There are some super powerful ones, and be honest with you, I don't know if I'm prepared to teach you all of the super powerful ones, but these are the basic ones. If you really enjoy this, go 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 check out some books online or in the library about codes and ciphers, and you can learn all sorts of cool stuff. And like I said in the beginning, if you really enjoy this, you can make a career out of this. You can make a lot of money by being a cryptographer. So I hope you enjoyed this. If you did, maybe shoot me a secret message and see if I'm smart enough to decode it. Okay, I hope you had fun, and I will see you around. Good luck, my cryptographers.